There's a problem on the actual midterm, like number 16, where you have to take the 3 and we plug it in for each one of the x's. Does everybody remember how to do that? So I put 3 in for an x and get 3 squared minus 2 times 3 plus 17.
Yep.
We're good with that, right? So we square the 3 and we get 9 minus 6 plus 17, and then we can just stick that right in our calculator. 9 minus 6 plus 17. Get our answer. Oh, what else we got? It's just finding them on this paper compared to the exam. It takes a minute. There's definitely then, by that same process, 33, that one's going to show up again on the exam. Anybody have questions on 33? Interestingly, that was exactly the same question that was on your test for that chapter on functions, chapter 4. So we just take the negative 2 and we plug it in first to the g equation. So we would have negative 2 times, and now in parentheses, I'm going to put in the negative 2 squared. Remember, I square the negative 2 first to get 4, and 4 times negative 2 is negative 8. Then I take that negative 8 and I plug it into the f equation. So I would have negative 8 over 3 plus 2, and I could leave it like that, or I could put that in my calculator and get some really nice decimal answer, whatever it is. Or I could get a common denominator and make that be fractions. That would be good stuff too. Questions about those? How about number 30? That one should be the easiest question on the whole thing. But a lot of people yesterday couldn't remember how they related the center to the equation. So just as a reminder to those of you who don't remember, the center of the circle is given by the numbers inside the parentheses. And what do we always do to numbers that are inside parentheses? We flip the signs. So the center of this circle is negative 9, negative 6. So as long as you remember it's these numbers and I just flip the signs, you should be good. The only other thing really I would caution you about too much, and we'll do a couple with exponents and logs, I guess we'll do the one ellipse too, is make sure that when you are looking at your problems you read really carefully. Because like this one says, graph. And that's all it says. Draw the graph. But then another one will say, solve. And you will draw the graph. They don't want you to draw the graph. They want to know what? They want to know the answers. Now I can find the answers by drawing a graph. Or I could FOIL this out and then multiply by 4 and use a quadratic formula. People did that yesterday. That takes a long time, but it will absolutely give you the answers. Okay? I could draw the graph and look for where it crosses the x-axis. I could even factor it. Right? But they really just want to know the x equals 1. That's what they want to know. They might even care that it's a double root at 1. But remember, when we had things like x equals 1 and x equals 3, or we had a problem where it crossed over here at 1 and 3, we could work backwards and we put those in parentheses and we said, well, that's x minus 1 and x minus 3, correct? So when it says solve and they give us something like this, we don't have to do all that work. We should be able to look at it and go, well, when I had it as a point, I switched it out to that. So now that I have it as this, I can just switch that and make it back to x equals 1 and x equals 3. But if you don't remember that, you still could graph this exact thing and find out again where it crosses, but they want you to actually solve. Here, they want you to actually solve. Tell me what it could be. Okay? Here, this one on the test we had a lot of problems with too. Write this as a polynomial in general form. It was strange, but interesting, that people got all kinds of random stuff. But we just multiplied the 4x squared times the x to get 4x cubed, and the 4x squared times the 2 to get 8x squared. Multiply it by both. And we did have a couple people who had random train wrecks and multiplied 4 plus I times 5 minus I and didn't FOIL at all and got 20 minus I squared. And some of them who were thinking they were extra smart and brilliant that day remembered this was -1 and said they got 21. Woo. Which would be great, except that you lost your inside and your outside. So you had half the right answer, but you were missing another part of it. So we want to make sure when we're doing those that we get all of our answer done. So the last ones then that are on the test that we haven't talked about are the ones like 36 and 37. 36 calls for you to remember that when you have something raised to an exponent raised to another power, that what do we do with our exponents? That'd be 4 to the what? 10. Good. Over b to the 4. Because I multiply my exponents. How about write as a radical expression? Notice this has two parts, because sometimes people miss both parts. Rewriting it as a radical expression. Well, I have to remember radical looks like that. What part goes on the bottom here? What am I putting there, Dustin? You only have two choices. This or this. Pick one. It's 50-50 chance if you're lucky. Pick one. The top one. Which one's the top one? That guy?
Sure.
You're wrong. That's okay. Next time you should be right. The 32 goes on the bottom. And the bottom of our fraction here goes
in the crack.
Crack. So we have the 5th root of 32. So the first thing we had to do is write it as a radical expression. 32 to the 1/5 is the same thing as the 5th root of 32. The second thing they ask us to do is evaluate that, or find the number that equals 32 to the 1/5. Seb, how can we do that? Lovely, I love that option as well. That would be what I would pick myself. And so I just need to put in 32, and then I remember my little fancy caret. And I'm going to put my 1/5 in parentheses so that it does the whole thing. And I hit enter, and I get 2. So part 1, write it as a radical expression. Part 2, it equals 2. Now you know. Questions?